yeah.
And that's
That will be
that's
nice.
that where, I have really kind of minimal commitments. I haven't been on a vacation in like way too long. Well, yeah,
Yeah, I
it's been a while.
bet. Yeah,
So
it's nice when you don't have to go somewhere and do something you're on your own schedule,
I
someplace
know.
new. Yeah.
Hey, did you see the eclipse, Terry? Did you see the partial?
Yes,
What did you
I
think of that?
actually did. I sat there for a minute and thought, okay, yes, it is getting darker. It was so small, but yeah,
Yeah, it was, what one one thing that was interesting to me was I was trying to see how far in advance I could see the penumbra. Would
yeah.
it be 20 minutes? Would it be 30 minutes? And I was able to see the penumbra 45 minutes before the
Wow.
partial and 40 and just about 45 after. And during the partial, I think it looked a little more eclipsed than it was because part of the penumbra was dark enough to take a little bit of a bite too. That was just my impression. I don't know what
Yeah.
yours is. Uh, it was pretty
It was the
cool.
same way though. It looked like it took a little more of a bite to me too, and I thought maybe it was just my imagination or my eyes, but it looked like more than I was expecting.
Yeah, I think the penumbra played a role. And so I'm
Yeah.
going to kind of keep an eye on the penumbra. I've become a penumbra follower since that eclipse.
I've actually taken a flight, an airline flight, to see a penumbral eclipse of the moon from the airplane.
Oh,
I think I'm the
yes.
only person who's ever done that. But
How is it? What did you see, David?
it was an eclipse that took place just 2 weeks before a total 20 years ago, and it was the penumbral eclipse was just kind of east of Tucson. So I got onto the plane, made sure I had a seat on the right side where I'd be able to see the moon, and I saw the eclipse. It was a total penumbral eclipse. Terry, would you mind if I did the quotation now so I can go to my other meeting and then come back
Let
here?
me, Scott, or we let him
Yeah, we're live right now, so I can
get us started
do that.
if
And
he's there.
yep, here we go.
All right.
Today, we're going to cook a comet. For this recipe, you'll need one comet, as large as you can find. Make sure it's nicely layered with ice and various other frozen compounds. Set it on track to head past our sun, and slowly turn the heat up as it approaches. Cook the outer layer of the comet in the sun's radiation. The material on the comet's surface will go directly from solid to gas. We call this process sublimation. The process of sublimation will help transfer the sun's energy away from the comet's crust, keeping it cool. Sublimate the water ice into water vapor. This will release trapped dust to trail off the comet. Notice how the comet forms a tail. Add ultraviolet light to the dust. This will help make our comet bright. The more dust our comet has, the brighter it will appear. Allow the vapor to escape to the comet's crust. These jets may slightly jostle it or cause it to rotate. Your comet will not cook evenly. The side facing the sun will sublimate faster than the other side. Bring the comet closer to the sun, and the tail will disappear. Materials are sublimating so quickly now, the vapors exist just long enough to appear on the surface. The sun's gravity will deform the comet into an oblong shape. Observe what materials continue to sublimate. This will give you clues about the comet's composition, density, and mass. Hopefully, your comet is strong enough not to fall apart. If it survives the sun's gravity and radiation, maybe one day it will visit us again.
Well, hello everyone. This is Scott Roberts and Terry Mann, and we are back with a special edition of the Astronomical League Live program. Terry, I'll let you take it away from here.
All right. Thank you, Scott. We have a great lineup tonight. What I would like to do is go right to David Levy and let him start us off for the evening. David?
Well, thank you very much. I'm going to have to go to another meeting, but I'm only going to be at that other meeting briefly because I don't want to miss very much of Bob's presentation. I'm really looking forward to that. And thank you, Bob, for giving us the time for this Astronomical League special event. My quotation is because last week I was at Palomar for the first time in over 30 years, and I saw our lovely 18-inch in the visitor center. But my quote, we also saw the lunar eclipse, which was really spectacular, I thought, far more than I ever thought it would be. And so in honor of that, I'm going to quote Thomas Hardy's 1903 poem, At a Lunar Eclipse. Thy shadow, earth, from pole to central sea, now steals along the moon's meek shine, an even monochrome and curving line of imperturbable serenity. How shall I link such sun-cast symmetry with the torn, troubled form I know is thine? That profile, placid as a brow divine, with continents of moil and misery. And can intense immense mortality but throw so small a shade, and heaven's high human scheme be hemmed within the coasts yon arc implies. Is such the stellar gauge of earthly show, nation at war with nation, brains that teem heroes, and women fairer than the skies. Thank you, and back to you.
You're muted there, Terry.
We will let you go. I know you have another meeting to get to right away, so hurry back and we will probably still be here. Thank you. All right. If it doesn't matter to Chuck and Carol, I'm going to go straight to Bob because I know Bob also has another meeting he has to get to. But Bob, I so appreciate you doing this tonight on such short notice.
Thank you very much, Terry. I appreciate it. And as I mentioned a few minutes earlier to you, I am a soft touch when it comes to comets. So do you want me to begin?
Well, we sure appreciate it.
Yes, this comet is certainly the most exciting thing. It's on the tongues of all of us. Everyone's talking about Comet Tsuchinshan-ATLAS. I used to keep a list of how many comets that I observed, and I stopped listing them at around 400. And I don't know how many I've seen at this point, but that's how crazy I am about following comets. I really, really enjoy them, including David Levy's comets too. So with that little bit of an introduction, let's go right to our slides, our presentation about the comet. I'll share my screen and we will begin as soon as I can find my slide button. There we go. Is that clear for you guys? Can you see it?
Yes.
Looks like we're good. So this is a very recent picture. It's taken by Daco in Mexico, and it was just photographed yesterday, or actually today is the 25th, this morning. And this is a truly unique image. First of all, the comet looks very impressive. At the moment when he photographed this, the comet was about magnitude 3. So he has a darker sky than we have at dawn to see this comet. So it stands out a little bit better. But what's amazing to me is it was taken with a drone. So there are multiple images here done with the drone and then stacked. And of course, when you stack multiple images, you get a very bright, prominent comet. But look at that scene there with the clouds. So I call this high hopes for Comet Tsuchinshan, and in parentheses, I have approximately how you pronounce it. I got tired of mumbling the words or calling it by its other name, which is C 2023-A3. So I've decided let's just try to pronounce it in Chinese. So Tsuchinshan. So we're going to talk about this wonderful comet this evening. And first, besides that picture, I've got some other recent images to show you. This was taken by Paulo Regis on September 23rd from Brazil. This is just to kind of whet your appetite and build excitement here. But here you could see it's starting to look like a genuine, the real article in the sky, where you have a prominent bright tail and a coma. All the observers so far, and all of our observations so far have been from the southern hemisphere. And virtually everyone who has observed it thus far has said that it has a very dense, bright coma, but and a longish tail, several degrees long, but that visually at magnitude 3 and competing with twilight, it's a rather faint object, but easily visible in binoculars. That will change very quickly. Here's a close-up, another one by Daco, taken on the 24th of September, where you can see a beautiful dust tail. Within this picture, there's also a gas tail. Comets typically have both, but the gas tail is a little too faint to see yet in the twilight sky. And it also, in at least one image I've seen, it overlaps the dust tail, so it's a bit difficult to separate them out. This is one of my very favorites. It was taken by Don Pettit. This is an animation that he made, multiple images of Comet Tsuchinshan-ATLAS coming up, rising right through the air glow. Isn't that intense?
That is cool.
Isn't that just the coolest thing? And he has continued to photograph it. There are new images of the comet too that have been taken, but I really enjoyed this because you can see it rise into the sky. Gorgeous. You know, no light pollution up there. That's a dark sky. But this is a very recent image. Now, I mentioned that most people have been seeing the comet from the southern hemisphere because that's where it's presently highest up in the dawn sky. But just today, Petr Horolik produced an image of the comet. He went out this morning and he stacked a bunch of images. He lives in Czechoslovakia and at 49.8 degrees north latitude. So we're talking US and Canada latitudes. He described the comet at magnitude 3, said it was not visible at all with the naked eye. That's this morning, but that it was faintly visible in binoculars. And here you can see it, and it does look very delicate, doesn't it? Right down there, you can see the faint tail, and then here is the coma. So it is visible now at our latitude and will be for the next few days. I'll go into that a little bit more in a minute. But it's probably for us, for most of the time its visibility in the morning sky, it's probably going to be mostly a binocular object. I'd love to be proved wrong, though. Maybe it'll shoot up to second or first magnitude before it dips back towards the sun. This is, or will be, hopefully, cross our fingers, it doesn't break up, when it approaches the sun at perihelion on September 27th, when it feels the greatest heat and gravitational tug from the sun. Hopefully it will not break up. If it doesn't, it should be an equal to Comet Neowise, although it will be visible throughout its best part of the apparition, low in the morning sky right now, and then after perihelion, it will pop into the evening sky, and it will be brightest when it's closest to the sun in the evening sky. So it's a little bit tighter, closer to the sun than Comet Neowise was back in the year 2020. But magnitude-wise, it should be approximately the same, right around 0, perhaps -1 if we're lucky. Just to do a little bit of background about comets, we see that gorgeous tail. That's what we normally think of as a comet. Bright head, gorgeous tail. It all comes down, every comet comes down to a very small, icy body that is embedded with dust particles, silicates, organic compounds, but it's embedded within the ice. And these small, irregular bodies very much resemble potatoes from your garden. If you've ever planted potatoes and gone searching for them, you'll pop up objects that very much resemble comets, including being kind of dark-skinned the way comets are. So these are spacecraft images. They're small. They're typically about 1 to 10 kilometers across. This particular comet, Tsuchinshan-ATLAS, is about 2 kilometers across to our best knowledge. As a comet approaches the sun, the ice that makes up the comet, and it's usually primarily water ice, but not necessarily. It can have all kinds of ices involved. Carbon dioxide ice, dry ice basically, carbon monoxide ice, methane, and so forth. So it's kind of a mishmash of ices, but primarily water. As it approaches the sun, the solar radiation vaporizes that ice, and within it is trapped dust. And the radiation pressure, which is actually the physical momentum of the photons leaving the sun, they actually push the dust particles back away from the head of the comet, from the nucleus, and they create the dust tail. So those are the small particles, and those bits of dust liberated from the comet are illuminated by the sun, and they glow kind of a pale yellow color. The solar wind, meantime, which is the steady wind of subatomic particles that the sun is blasting out every day, the solar wind energizes cometary gases, in particular carbon monoxide. The UV light from the sun, I should say, energizes carbon monoxide and causes it to glow blue. So you get a second tail, which is blue colored, again, primarily CO, carbon monoxide. And then the wind itself, the solar wind, blows that gas directly behind the comet opposite the sun. So it's stretching and shaping the gases that are leaving the comet. And those are ionized gases. They're ionized by the sun's UV light. And so the solar wind and the direction of the magnetic field that accompanies the solar wind controls what happens with the ion or the plasma tail, that blue tail. If the solar wind direction changes, that tail can be snapped off and another one will grow right in its place. One of my favorite comets, one of the ones that really got me interested in comets is 67P, Churyumov-Gerasimenko. Here you see it in an image taken by the Rosetta probe, which hung around and orbited the comet between 2014 and 2016. All those other images were flybys. This was, we're sticking around. And then they finally actually landed the craft on the comet when the mission was over. But you can see the irregular shape. You can really get a sense of the sun drilling into and vaporizing, called subliming, but vaporizing works too, vaporizing pockets of ice across the comet and shaping it through the vaporization of ice. And the dust is being blasted out through those jets. This is an awesome image of a single jet in action as the Rosetta probe passed directly over it. So you can see right here, this spot on the comet's surface, which actually turns out to be a cavity in the comet's surface. Yes, the icy surface vaporizes, like you saw in the video before this program, but there are cavities that lead to subterranean depths in comets, and fresh ice beneath the surface of the comet vaporizes and blasts out through these cavities into space as jets and carrying dust, which helps create the tail. Another favorite image taken by Rosetta, it's a sequence. There's a few cosmic rays running through here, but it's mostly dust that you see. Some of that dust goes out into space, some of it lands back on the surface. Comet environments are just unbelievably active. Someday I wish somebody could create a virtual reality experience of being on one. Because of all of the cliffs and boulders, things get undermined. You know, as the sun heats them and the ice vaporizes, things just collapse. A jet could form underneath a boulder and blast the boulder up from the comet's surface, or undermine the boulder and cause it to roll downhill. So it's it's like a morphological madness of a place, the comet's surface, when it approaches the sun. In all of this activity, in the case of this comet, 67P, it lost like about 3 feet of its surface. That's what it loses every orbit. That's what vaporizes away. Here's a nice image taken hours apart, 2 different images put together so you can get a sense of the landscape of this comet. Look at that. Talk about forbidding. I don't care. I still want to be there. So let's get right to our comet again. You got a nice taste of what it currently looks like based on images taken primarily from the southern hemisphere, but one from Czechoslovakia. This comet was discovered by back in January of 2023 at the Purple Mountain Observatory in China. And it was named, the name Tsuchinshan actually means Purple Mountain. So when you say that word, you're saying Purple Mountain. So we could call it Purple Mountain Atlas too, as the name of the comet. It was also independently discovered by the ATLAS project. Now, when it was first found, it was just like a blip, and it was reported as an asteroid, magnitude 1819, and it went unconfirmed. So it was basically lost. But the ATLAS project, which is a survey looking for any moving object in the sky that could potentially pose a hazard for the Earth, was rediscovered by ATLAS. And then they were able to find archival images and determine, no, this is not an asteroid. This is actually a comet because they saw a very tiny, dense coma and additional images made of Tsuchinshan-ATLAS. And that's why it has two names, of course. Orbit determination found that our comet, our featured comet, originates in the Oort cloud, one of my favorite places too. I like refrigerated areas. That's why I live in Duluth, Minnesota. It's like living in the Oort cloud compared to Miami, for instance. It's a giant comet repository. It's just this area of all these little bits and pieces of ice and dust that were never incorporated into the planets or asteroids of the inner solar system. It's just sitting out there at an unbelievable distance, 1.5 trillion kilometers away and more. This comet dropped in from the Oort cloud, which means it has been traveling towards the inner solar system for millions of years. And how fortunate that we happen to be alive and around to enjoy its arrival. Here's a view of the Oort cloud where it's located. Still blows me away how far it is. It's actually beyond the sun's influence in terms of its physical or radiational influence, I guess you could say. It's beyond the heliosphere, and it's located in interstellar space, but it's still gravitationally bound to the sun. Here's a view of the comet's orbit. Like a lot of comets from the Oort cloud, they come in at every different direction, right? Which is the reason we think the Oort cloud is a sphere in the first place. So this comet has an orbit that is inclined 139 degrees, and it is currently below the plane of the solar system, working its way up. This is its position right now, today on the 25th. Here it will come up, swing near Earth, and then head north above the plane of the solar system, just to give you an idea of the general track. Now, we had to wait like a year before we could see Comet Tsuchinshan-ATLAS in a telescope. I spotted it myself for the first time on a very cold January morning here in Minnesota. It was about 13.5 magnitude. But even then, I was excited to see it because the coma, the inner coma, the head of the comet, it was so intensely bright for being such a faint object. I took that as a good sign that this thing had some lasting power. And as it turned out, it apparently does, because it's still with us and the forecast is still good. Gradually, as the comet approached the Earth, it and the sun, it grew a longer tail, took on this most beautiful shape. I hope some of you got to see the comet back in spring when it was approximately 10th magnitude, and it exactly had this teardrop shape. This teardrop shape is typical of comets that are very rich in dust and have large dust particles. That is going to turn out to be a really good thing for us. I made a sketch of it in my scope. This is with a 15-inch 142X, and you can see it looks just like the photograph. It's very bright coma in there. Of course, the nucleus itself, the comet body, is not visible, shrouded in the dust that it's producing as the sun is working it over. The comet gradually approached the sun and moved westward and slipped away from view. And it was out of view beginning in early August. And we were all like, what's going on with the comet? So it was viewed for a time in various spacecraft, like the SOHO spacecraft that orbits the Earth and studies the sun. So we did get some views of it. But then everybody was really ramped up on September 11th when Terry Lovejoy, yes, Terry Lovejoy, a comet discoverer himself, 6 comets for this guy, he recovered the comet on the 11th. And Terry worked hard, because there it is at dawn from Australia. It was only 14 degrees elongation from the sun. This is an amazing image to me, even though it doesn't look like much on the surface. So as I mentioned at the beginning, Australian, Brazilian, South American observers have all been watching this comet for the past week. It's been gradually rising. It's been brightening as it approaches the sun. It's finally getting to a declination where it is becoming visible in our sky in the mid-northern latitudes. This is a sky and telescope chart showing you the approximate location of the comet down below the star Regulus, very low above the southeastern horizon. about an hour before sunrise is a good time to go out and look. So it will be visible. Again, some people have already spotted it. There's a guy in Texas that took a picture. You saw the Czechoslovakian image. But from Minnesota, at least, I calculated it's going to be visible from the 26th through the 30th. Just a brief jump up, and then it's gone. So these next few nights are the time for all of us, wherever you live in the United States and Canada, to make that attempt to see it in the morning sky. It's very low down in twilight, directly below Regulus. It should reach magnitude 2 or thereabouts. Right now, it's at 3.0 approximately. And you can use the moon. Here's the good news. You can use the moon on the 29th and 30th with Regulus to kind of swing you down there to see the comet. Plus, you get to see this awesome thin moon. And that, that's enough for me, even if I don't see the comet. I'm planning on going out tomorrow. As I look out my window, it's still clear. So I've got my fingers crossed. So the old moon helps the way. You need a great eastern horizon. You may only have 15 minutes or something. The comet may only be about 3 or 4 degrees high at maximum for you. So be sure you got yourself a good horizon in that direction. And a giant fan to blow away all the clouds that are hanging out in that direction some days. Those who have studied comets and who enjoy watching them know that some, like people, some are gassier than others. So, for instance, we have this comet. You might recall the green comet of the winter of 2023, very gas-rich comet. The color green that you see, which is even visible to the eye when you look at a comet through a telescope, it's quite vivid sometimes. This is produced by the emission of diatomic carbon, C2. That is the visible light emission of green from a comet. And if you see a lot of green in a comet, it's a gassy comet. Comet Tsuchinshan-ATLAS is different. It is not so gassy. It is primarily a dusty comet. And again, that's a fortunate thing for us because fine particles like cigarette smoke, water vapor, and dust are fantastic at forward scattering light. As you can see in these two images, we have the light source is behind this guy's head, and here he's breathing out. And you've all seen this in the winter where someone's breath is just brilliantly white. And it's because the light from the source that's hidden and nearly in line with your line of sight is being forward scattered off those bits of moisture. For the same reason we can see these plumes on Enceladus, because they're backlit. That's another way of calling this. It's backlit by the sun. The more backlit, the brighter the plumes, the brighter the breath. And believe it or not, just today when I was coming in after walking the woods, I noticed one of these dandelion seed heads in my yard. And I thought, oh, look at that. That thing is forward scattered in a massive way. So I took a picture of it in the sun's direction. Look at how bright it is. And then I held it off to the side. Still kind of bright, but it lacks that brilliance. It's not forward scattering the light. So forward scattering, if you've got a grasp of the concept now, I hope you do, is related to the comet's phase angle, which is our line of sight towards the comet in relation to the sun. So as the phase angle of a comet increases, in other words, as it moves more directly into the line of sight of the light source, which is the sun, the more intense the forward scattering becomes and the brighter the comet becomes. And if you got a dusty comet like this, and it's going to have a high phase angle, then the potential for a ramp up in magnitude is great. So C2020, there it is. I did use that term, C2023A3's phase angle. You can see on the diagram on the right how phase angle works. It increases now through early October as the comet gradually comes into alignment with the sun. And it will rapidly brighten. And here's how much it's going to brighten. These numbers come from comet researcher Joseph Marcus, and some of these were published on a CBET 5445. And what we have here are the dates, universal time. here's the comet's phase angle. Okay, you notice that it's increasing, reaches a peak of 173 degrees, which is almost 180, and then it begins to decrease. This is the comet's base magnitude without any forward scattering factored in. So at best, this might just be a second magnitude comet. Not bad. But look what happens when we add the phase angle addition. The comet gets these are the additional brightness. This is how much brighter the comet gets just due to forward scattering. And as you see, that affects the final magnitude, what you'll actually see with our eyes on the column at the far right. I hope you can see that here in this. And you'll notice that the comet is going to be a lot brighter than at first glance. So we're going to look at first, as it passes perihelion, what we might see. And then when it flips over after perihelion into the evening sky. So we have a comet that is a dusty comet. It's ideally placed to get a significant brightness boost from forward scattering. That means that careful observers, as you notice from the negative magnitudes on the table I just showed you, careful observers may be able to see the comet in the daytime sky at around magnitude -2, perhaps as bright as Jupiter. It's going to be near the sun, so you're going to have to be super careful to keep the sun out of the view. You might be able to use a roof line, totally block the sun, and then a pair of binoculars. See if you can spot it. You probably won't see a tail, but you might see the bright head of the comet. And this is how it moves across the daytime sky as it's headed towards the evening and dusk sky. Some of you may have seen, and I bet David has, Comet McNaught. This comet was also super dusty, and it was in a great position so that forward scattering boosted its magnitude. And it was visible in broad daylight. I remember looking at this thing in my telescope just from my front yard. You could see the coma and a little bit of flaring from it. No problem at all. The magnitude of this, though, was -5.5. So significantly brighter than we would expect Tsuchinshan-ATLAS to become. I'm still counting on it, hopeful. So as you look at this illustration, this sort of simulation of the comet, on the right is its visibility, its position in the daytime morning or in the morning sky, and then watch how quickly it brightens as it passes in the direction of the sun, like that dandelion. And then it flips over into the evening sky and gradually begins to fade, but it will have a long tail. We're expecting a tail of about 10 to 15 degrees. There'll be an ion tail and a dust tail. So this is the comet again on the right in the morning sky, and then it moves past the sun at perihelion and then into the evening sky. So while we can go out in the morning sky to see the comet, twilight really interferes with it a great deal. The best part of the apparition, when things get rolling and the comet returns to view and then stays with us all through the fall, that begins about October the 12th. We have not only the high forward scatter when it first comes into the sky down here on the 12th, but it will have just past perihelion, which means the sun will have just raked it over the coals, so to speak, so that it will have ejected as much dust as it can. When comets are close to the sun, they can really kick out a lot of extra dust. So circumstances are ideal. Past perihelion, and then it comes closest to the Earth. So we should see a pretty bright comet around, perhaps as bright as Sirius when it first appears in the sky. So it should make an unbelievably wonderful thing, as long as it doesn't break up at perihelion. I'm told that at 2 kilometers across, it probably will survive. It's survived to this point. But you can see here, the green numbers are the magnitudes that we expect along the path. And that's a long time, isn't it? That's several weeks of a comet being visible with the naked eye in a dark sky, and certainly visible in a pair of binoculars. So I think there are lots of public opportunities for us to get out and share this comet with people, identify a great place with a Western exposure, unobstructed view, and get those telescopes out and get people to see the comet. We do have a moon, of course. Naturally, this being amateur astronomy, the moon will always interfere when you least want it to. So we have some moon interference occurring between the 15th and the 20th. But there's lots of time on either side for viewing the comet at its best. I always recommend the stargazing app for people. And if you're looking for one to recommend to people, Stellarium Mobile, which is free. It's on Google Play and the Apple Store. Super easy to use. Tap the time here. You tap up at the top on the magnifying glass, the search function. You type in C 2023 A3, boom, it has the comet, and it will show it to you just like I've got it right here. And then you can hold it up to the sky, your phone, and locate it that way too. Binoculars. I like to always emphasize that having a pair of binoculars with you always enhances a comet. It really makes them extra beautiful. You see so much more detail in the tail. And you see more color too sometimes, especially in that pale blue ion tail. I recently bought a sea star and discovered that it was an excellent instrument for photographing the comet. This was taken back on June 1st, and the comet was 10th magnitude at this time. So if you have a sea star, this would be a great chance to set it up and see what you can get. You might have a telescope here where you're doing some observing. Just let the sea star do its thing. And then if you've got people around, you could show them on the phone the image and then say, hey, come take a look through the telescope too, now that you know what to look for. A couple more images. This was taken a little bit ago, about a week ago, September 17th at dawn, reached magnitude 4.3. Of course, now it's brighter, 3.0. Here's a view from September 17th from Namibia. And here you can see two tails on the comet. There are actually three, but we can't see the ion tail because of the bright sky. This dust tail is a recent one that is composed of exceedingly tiny grains that have been fluffed away, liberated just recently in the past month. So it's kind of a new tail that formed on the comet as it's closing in on the sun. And the larger particles are breaking up into smaller ones. So you have these very tiny grains. That's what you're seeing in all of the pictures tonight. It also has sort of like a shadow type tail here. This tail is actually the grains of dust, the larger ones that were deposited along the comet's orbital path during the spring months. And they form what we call an anti-tail. So this comet not only has an ion and a dust tail, but because of orbital geometry, it should have a spectacular anti-tail, perhaps as good a tail as we saw back in 1957 with Comet Ehrengrauland. Take a look at this simulation again, and you will see the anti-tail form, not here, but watch as it swings by the sun. The anti-tail will appear to stick out opposite the head of the comet. There it comes. On the right, there's the anti-tail right here. It's kind of faint, but maybe you caught it right there. So dust, ion, and anti-tail. Couldn't ask for more. Probably maybe a sodium tail, who knows? The best time to see the anti-tail is when the Earth lines up along the comet's orbital plane. This is a bit tricky to show. You're looking down on the solar system. The Earth is off to the right. We are looking upward towards the comet's orbit. We are in the plane of the orbit, way behind it, so there are no meteors or anything coming from this comet. But we're looking across the orbital plane, so all that dust that was fluffed off, spalled off during perihelion, that dust will be seen behind or below the head of the comet as an anti-tail. And again, as I mentioned earlier, it might look something like Comet Ehrengrauland did in 1957. Another thing to watch for, this is the first photo I've seen of this. Occasionally you'll see, this is sort of rare, you'll see a bifurcation of the tail where it looks like there's a shadow. People sometimes call it the shadow of the nucleus of the comet. And you can see it here in this Gerald Raymond image taken on the 25th. Look, there's a little vacuity here, just a little gap between one half and the other half of the tail right down there. It looks like the shadow of the nucleus, but it's actually that's not what's happening. What's happening is, this looks kind of crazy, but stay with me. This is sort of well, it's a fountain, right? It's a decorative fountain. And what it is it serves as a wonderful model for the comet's nucleus. Here's the nucleus down below where the water's coming up. We have the sun here heating the nucleus. Those are the jets shooting out. Their dust is coming, wrapping around the comet and streaming down the tail. And so when we look at this with the water and with comet dust, you see that over here on the left and on the right, more streams are aligned. So it looks like the comet is brighter. It gives it, actually, a comet's tail is tube shaped. If you can see this as a long tube. And we see it brighter on the sides because we're looking through more dust around the curvature of the tail on the sides. So it's not actually a shadow, but it's a fascinating phenomenon that we can see with some comets, usually the brightest. And this comet is already showing it. So this is my final slide. And it shows my hopes and dreams. I'm sure it won't look like this, but Comet McNaught was a wonderful bright comet, very bright, very dusty. But who knows? And that's what's so great about comets. We just don't know. They're kind of like people. They just do these unexpected, surprising things. They're a bit predictable, but not always. So potentially it could be magnitude minus 1.5 in mid-October at dusk, low in the southwest sky with two nice tails. And then on the 14th and 15th, right then you're going to should see a prominent anti-tail. So reserve some time, plan on losing some sleep for this comet because I think it's got some wonderful surprises in store for us. And with that, I'll finish the presentation. And if there are any questions, I'd be happy to answer.
I have a question, not a question, but a comment.
Yes.
Bob, I thought your lecture was wonderful. It was emotional, and you captured the joy and the fun of looking at comets.
Oh, thank you.
When I did my quotation earlier, I clearly did the wrong one. I did the Hardy poem about eclipses, when I really should have honored you, which I would like to do now, with a line from Leslie Belcher. Time has not lessened the age-old allure of the comets. In some ways, their mystery is only deepened with the years. At each return, a comet brings with it the questions which were asked when it was here before. And as it rounds the sun and backs away toward the long, slow night of its aphelion, it leaves behind with us those questions still unanswered. To hunt a speck of moving haze may seem a strange pursuit, but even though we fail, the search is so rewarding. For in no better way can we come face to face, night after night, with such a wealth of riches as old Croesus of Egypt never dreamed of. I just wanted to share that with you, Bob. It was wonderful, and I'm so glad I got this lecture.
Oh, so that was just, thank you so much, David. And that it couldn't have been a better ending. I just love that quote from the poem. That was really good. And it really gets to the heart of comets too. It's just, we have all these questions. They come, we try to get answers, then they leave towards their aphelion. And we wait for the next, we marvel, and we keep asking. So fabulous.
Great. Great. And I have a question. My question is, out of all your years of observing comets, and all the new stuff we've learned, with the spacecraft visiting them and stuff, and those stunning images that we now have of comets, within the span of our lifetimes, we've gone from just kind of blurry images on film to things that are just absolutely incredible. But what is the most surprising thing to you out of all your time looking at comets? And I know you're a deep thinker about what's going on in the cosmos and how it affects you and your place in the universe. What has been maybe the biggest surprise to you?
Oh, well, maybe just two thoughts on that. I have. Thanks, Scott. I think the first thing is how a comet is, it's almost like a metaphor for life for me because, and that's why I like to see comets from beginning to end because they start small, like little babes, and then they grow and they become these magnificent creatures, in their youth and vigorous, and then they lose their tails, like I'm losing my hair, and they fade and they go away. And I love seeing the human life cycle repeated in comets. So I generally like to start and finish with them, see them all the way through rather than wait for them to look really wonderful. So every aspect is important to me. And then perhaps if you're talking about just like a most amazing sight I've ever seen the comet, I guess there are two, all right. Comet Shoemaker-Levy, the pieces that hit Jupiter and made those big black spots,
Yeah.
courtesy of Dovey. And then the second thing was when Comet Holmes underwent a massive outburst back, I can't remember what year it was, 2000 something early. And it suddenly became this star-like object. And then it bloomed into this naked eye comet just in a matter of days. Just the how quickly and surprisingly comets change has always kept my interest and fascination. I find they're just amazing. And
Yeah.
and finally, sorry, maybe one more. I like that they're made out of virtually nothing. You could take that whole blue ion tail, crush it down, and stick it into a sandwich lunch bag. There's like nothing there. Even comet dust is.
Wow.
So if you
So
look at what
tenuous and
nature
yet so
can do,
dramatic. Yeah.
oh yeah, but you look at what nature can do with so little, it can create these absolute wonders. And that to me shows you the depth of nature's ability to stir our souls. So I love that about comets
I
and
love
many
that.
things in
That's
nature, but
very well said. Very well. Well, that's
I,
great.
I'd just like to add something if I might. I had the privilege of seeing Bob speak in person up in Green Bay, actually De Pere, Wisconsin, earlier in the year. I have never seen as dynamic a speaker as Bob King. And all I can say is invite him because you will not be disappointed. He spoke on Aurora at that time, and he's animated and enthusiastic, and it's infectious, and it's something to see. It really is. And I'd like to add one other comment. I had the opportunity to see the Bayeux Tapestry once, which has an image of a comet, Halley's Comet, and of course, that's depicting, this tapestry depicts the events leading up to the Norman invasion of England. And it just shows you the importance that have been attached to comets for well over 1,000 years, and certainly before that. And Bob, thank you for another great talk.
Well, thank you, Chuck, for your kind words, really. And that was a really good thing to bring up about the Bayeux Tapestry because it shows how these celestial objects, even though they're so remote, they play into human lives. They create meaning in our life, if we choose to let them in. So yeah, absolutely.
There's a couple of comments here. One, Alan Dyer's watching. He says, great talk. Thank you. And Rich Kraling, watching on YouTube, says,
Yeah.
Bob was terrific when he spoke at our star party at Hidden Hollow. So
thanks, guys. Thank you, Rich. And thank you, Alan, very much.
Carol, you're muted.
You're muted, Carol.
you're muted again. You're muted again, Carol.
There we go.
There we go.
Yeah, I liked your last comment when you said there's hope that we might have an extension of how long we can see it. I really like that.
Well, amateur astronomers, we are the most hopeful people in the world, aren't we? Or perhaps the whole universe.
Sounds like it's in a little better location once we get further into October as well.
Yeah,
Actually.
October. I think we only have a few days of seeing the comet before it actually starts heading back down towards the sun, like on the 29th. So it's already losing altitude again. So it's just that little interval in the morning, but then far more leisurely in October. So yes, I think it should be a very nice comet. Should make a lot of
Having it in the
photo
evening.
opportunities too. Yeah, just a telephoto. You don't need a telescope to photograph this comet at dusk. I think like a 200 millimeter lens should be wonderful.
Yeah, I think having it in the evening too. You don't have to get up in the morning. You can stay up in the evening, watch it from the very beginning or as soon as it rises. So,
You have to
is there
check your
any?
location carefully if it's that close to the
Yeah,
horizon, now 3 or 4 degrees.
yeah, that's going to be tough.
It will be tough. Yeah, finding that spot is key, where you can get a good view. And yeah, I'm sure some of us will be thwarted by, that band of clouds right there on the horizon sometimes, but any clear night
Yeah,
is worthwhile going out to check it out.
that happens. All right. If there's no other questions, I know Bob needs to get moving. He has somewhere else he needs to be too. Thank you so much for doing this
Thanks,
in
Bob.
such a short notice. I
Well,
really appreciate it. I'm sure
Well done.
everybody does. That was so interesting.
thank you very much, Terry. And I had a blast. So
We did too.
we'll see you all soon. I
Okay,
appreciate
take care.
it.
All
Take
right,
care.
Bob. Take care.
All right, take
Thank
care.
you.
Clear skies.
Bye-bye. All right, I've got Chuck and Carol here. Chuck, you did not get a chance on AL Live. Is there anything that you would like to say tonight or any news you'd like to update or anything?
Well, I'd like to tell everyone or remind everyone that we have a convention next year at a most unusual place and an exciting place if you're into observing under skies approaching a perfect dark SQM22 type sky. And that's at Bryce Canyon next June 25th through 28th. Bryce Canyon, of course, is a national park in southern Utah. And our convention will be held at Ruby's Inn, which we have a block of 275 rooms. And they're going fast already in September. I think we already have a third that number of registrations already for this convention. So you want to grab an opportunity to go to this convention. Lots of telescopes we will be observing in the national park. All I can tell you, if you've never seen a Utah sky, you're in for a treat. We've been holding astrophoto competitions at a number of our conventions, and we're going to hold one at Bryce Canyon next year. We provide these incredible looking medals to our winners for first, second, and third place in multiple categories of astrophotography, and they're engraved on the back. And if you want to get in on that, please come to Bryce Canyon next year. It's close to Zion National Park. It's close to the Grand Canyon. It's close to Las Vegas. You can make a heck of a vacation out of it if you come. I will add that these astrophoto competitions and these medals are being provided, or competitions with medals are being provided by the League also at a number of our regional conventions. Terry and I will be at Hidden Hollow this weekend. I'm leaving tomorrow morning for that. And we will also be providing astrophoto competitions again at the North Central region and Mid-States region conventions next year. So if you want to participate in those, please join us. And I won't go into anything else at this time, but I hope you will come to some of these conventions because they're exciting and a lot of fun. Thanks, Terry.
Thank you, Chuck. Carol, how about you? It's good to see you. I haven't seen you
Yeah.
since KC.
Yeah, good to be here. I haven't got anything
Yeah.
further to offer. We got a lot of exciting things coming up, and we're certainly looking forward to the Bryce Canyon. I know our registration is coming from all corners of the country. I have a feeling we'll have some international visitors before it's all over. So it's really creating a lot of excitement.
Yes, it definitely is. Also, Chuck didn't mention, Chuck is the new president of the Astronomical League. and there's a whole not a totally new executive committee, but there's new officers, and we're getting everybody together here in the next month. And Carol is our immediate past president. He has ran all the terms that he could run, so he stayed there and worked and worked and worked. And now Carol has stepped away a little bit, but he hasn't gone far. We'll be inviting him back and back and back. So thank you for being here, Carol.
Well,
and I would like to say, everybody join. Oh, I'm sorry, Chuck, I'll get you in a
well,
minute. Everybody join us at Hidden Hollow this weekend. There will be a Great Lakes regional meeting too, but there'll be a lot going on at Hidden Hollow. And as Bob said, it is a lot of fun. It's a great place to be. So please join us there. And Chuck, I'll let you say what.
I just wanted to say that Carol can't get too far because he doesn't have the combination to the lock on his leg chains. But
Darn. Oh, I thought I was going to get to Betty's list. Maybe I'm saved after all.
Carol, by the way, for those of you who are not aware of it, served a total of 4 terms as president. He had 2 terms back earlier in this century, and then 2 more terms recently. It's the first person ever to do that.
Yep.
I'll tell you, I've served with some great people, and the new leadership is going to take it to the next rung as well. And I'm really excited about where they're going to take us. So it's going to be a good journey.
Thank you, Carol. And thank you, everybody. I know this was a short notice program, but we wanted to get Bob on here and hear some more about the comet. So thank you, everybody. If no one else has anything else to say, I'm going to turn it back to Scott to go ahead and close it out. But thank you, everybody, for being here. We really appreciate it.
Well, thank you, Terry. Yes, we have, you know, I would be remiss in not recommending that people join the Astronomical League. I did put in chat, into the live chat, the direct link for membership. It is a fantastic organization. It is, I think, the world's largest organization of the amateur astronomers, certainly the largest federation of astronomy clubs in the world. And they put on fantastic events, you know, of course, one of them being Alcon, but they also have regional Astronomical League conventions that are very, very informative and a great way to get to meet and join up with old and new friends. And so, and with all their, you know, observing programs that they have, their awards programs that they do, you know, there's nothing like the Astronomical League. And so, so anyways, I'm very happy to be there to help support them in the way that we can. We do underwrite the National Young Astronomers Award, the Leslie Peltier Award, and the Wilhelmina Fleming Award right now, which is kind of a more recent astrophotography award for specifically aimed at women. So I also want to say that we will have our next Global Star Party, which the Astronomical League always participates in, and that will be on October 1st. And so that's going to be very interesting. And this time the theme is Cloudy Nights. Was suggested by David Levy, and so I took the privilege of inviting the guy that is behind Cloudy Nights, which is Mike Beeler at Astronomics, and he's going to give us some background on what Cloudy Nights has offered and continues to offer as one of the world's largest user groups on astronomy that covers, you know, virtually every aspect of gear and events and anything to do with amateur astronomy. So you're not going to want to miss that. And what else is going on? Well, we got this big comet that that you heard Bob King talk about. I'm so excited to go and see it myself. So as I know all of you guys are. So thanks again for letting us invade your evening. And I have a couple of videos that we'll be showing here. You guys have a great night. And thank you, Terry and Chuck and Carol for being there. So
Thank you, Scott.
yeah, take care.
Thanks.
When I began with the Sungrazer project, we had less than 1,000 comets. That was over 20 years ago. So the fact that we've finally reached this milestone, 5,000 comets, is just unbelievable to me. Sungrazer project is a project that allows anyone, anywhere in the world to sit down with a laptop and discover comets. The clue to what a sun-grazing comet is kind of in the name there. It's literally a comet that grazes by the sun. The Sungrazer project relies exclusively on images of the sun from spacecraft, and the images that we discover nearly all of our comets in come from the Solar and Heliospheric Observatory, or SOHO. That is a satellite that was launched in 1995, so it's been operating for a long time now.
3, 2, 1, ignition, and liftoff of SOHO and the ATLAS vehicle on an international mission of solar physics.
Our participants go to the SOHO website where we have all of our latest images from the spacecraft, and they download those images, and it's really as simple as looking through them, flicking through the image, and looking for something tiny and faint and moving in a different direction to the stars. Discovering a comet is a very unique feeling. You have this realization that suddenly you've found a piece of the solar system, a piece of the universe that no one has ever seen before. Prior to the launch of the SOHO mission and the Sungrazer project, there were only a couple of dozen sun-grazing comets on record. That's all we knew existed. The 5,000 comet milestone is a huge achievement. It's one that none of us dreamed we would even get to. So simply the statistics of 5,000 comets and looking at their orbits and trajectories through space is a super unique data set. It's a really valuable science. And it is just a testament to the countless hours the project participants have put into this. We absolutely would not, under any circumstance, be here if it wasn't for what our project volunteers have done. That's really what 5,000 comets represents. It's 20 or more years of invaluable discoveries from the project volunteers.
I think one of the age-old human questions, perhaps going back to the beginning of humanity, is, are we alone in the universe? And that maps directly into, why are we here?
OSIRIS-REx is 3 missions in one to make that kind of exploration cost effectively for not much more than the price of a blockbuster movie.
There's been nothing like OSIRIS-REx in NASA's repertoire. I like to call it the Daredevil spacecraft.
We're going back to the dawn of the solar system. We're looking for clues as to why Earth is a habitable world. And of course, the biggest question, the one that drives my scientific investigations, is the origin of life. What is life? How did it originate? And why was the Earth the place that it occurred?
10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1.